Hi, hello, vanakkam, and welcome back to yet another episode on your favorite Little Salah YouTube channel. So today in this video, we're going to see about uh, it's been a long-term question for me. So what's the performance testing approach for on-prem to cloud migration? So we're going to see how to do it, and we're going to look into various infrastructure related and basically we're going to understand how the cloud migration is going to reduce the infrastructure cost and how are we going to approach this, what are the approaches that we're going to follow. So starting with the very first one, that is the digital transformation, scalability, cost, efficiency. So when talking about all these, so migrating to cloud is like switching from your own car. So you have a car, but now you are using Uber, so you only pay for what you use. So if you're uh, uh, spending a lot on maintaining the vehicle that sits idle most of the time, so you're not using all the time, but or not all the time, only when you use it, when you're going for a shop, when you're going to the airport, when you're going to pick someone, when you're going to drop your kids. So only these scenarios you'll be able to utilize your vehicle. But when it is Uber, you're going to pay only when you're going to use. So this approach is being replicated in the cloud, in the IT infrastructure as well, where we're going to save, or where the business is going to save millions of money by eliminating any necessary infrastructure cost. So let's break it down a little bit deeper. So first thing is there are going to be no more expensive hardware. So that is what the main. Uh, so when I talk about the hardware, so this is about the reduced infrastructure cost, and when it's going to be like pay as you go. So you don't need to buy servers, you don't need to buy big storage, networking equipment, and keep on upgrading them with each and every single patch and each and every single security updates. And in fact, you need to employ a lot of people to manage them as well, right? But when it comes to cloud, you're going to rent the computing power from providers like the AWS, Azure, Google Cloud. So there are going to be no upfront hardware cost. So taking for a real life example, you're running a pizza shop, and if you buy 10 ovens, but only you use five, so you're wasting money on the other five. What cloud does it lets you rent the ovens only when it is needed. So this will actually help you to cut the cost. And then the famous lines, that is pay as you go pricing. So by doing this, you're not going to waste any unused resources. So you pay for the full capacity even if you don't use it in on-prem, but in cloud you're going to scale up, or you can scale down based on your demand, where you're going to pay only for what you use. So a real life example is, think of Netflix on weekends, where you're going to like people, like millions of people, they stream movies, so they scale up the cloud service, right? But on weekdays there are only few users who are going to watch it, because we'll be busy with our daily day-to-day office activities, and kids will be doing their homework, they'll be doing their study work, so nobody's going to watch on weekdays. So what happens if you are having the same set of hours all the time? So instead we can spin up and then we can spin down the service based on our requirement, based on our needs. It's very reasonable, right? And then there is going to be no maintenance cost. Yes, cloud providers will handle it, will handle the maintenance. So when in on-prem, and even in the first statement I told you, in on-prem you need IT staff, you need network engineers, you need server engineers, and much more. Even firewall engineers, storage engineers. So you need to have multiple different IT staff to maintain the servers, to fix the issues, to upgrade the hardware. But in cloud, the provider, which is AWS, Azure, GCP, they handle the maintenance, they handle the security, they handle the updates that you save on your labor cost. And when it comes to real life example, owning a car means you're going to pay for its repair. You have to take it for repairs if something happens. You have to pay the insurance monthly. You have to refuel your car. But when it comes to Uber, you're not going to pay any maintenance cost. Instead, book it, pay them, get out. That's it. So there is going to be no maintenance cost. And when it comes to lower energy and cooling costs, so in on-prem, the servers consume massive electricity and it needs cooling systems. Again, cloud also needs, but the approach is different. Data centers are optimized for efficiency, which reduce the energy cost, because their main objective is to run data centers. So they plan everything based on that. So a real life example, so you're running a fridge at home, which costs more than using a shared fridge at work. So cloud computing is likely sharing your resources to cut your cost. And then the faster innovation. So when it is faster innovation, it's more savings because in on-prem, even for upgrading the infrastructure, it will take months and it will cost millions. But in cloud, you can deploy new features instantly, which reduce development costs. So quick real life example is just launching a new app on-prem is like building a theme park, which take years, but cloud is like renting an amusement park, just instant access. So instead of just saying cloud saves money, I'll say that the old systems, the on-prem, where you live in a mansion, but you pay for every empty room. But in cloud, after you migrate, so you move into a smart apartment that expands or shrinks based on your needs. So when your friends comes, the rooms gets expanded, and when they are outside or when your parents comes in, when your relatives comes in, the room gets expanded, and when they go out, automatically they shrink. So which means there's going to be no wasted space, there's going to be no wasted money. So just to give you on what all the infrastructure changes that happens, we have to understand that right before we move even do the performance testing. So the what are the items that will be removed in on-prem infrastructure? Say for example, when you're migrating from on-prem to cloud, the business replaces the outdated physical infrastructure. So what they do is they remove the physical hardware, the dedicated servers, where you had racks of physical machines in a data center. The storage devices, you had HDD, you have SSD for local data storage, the networking equipments like routers, switches, firewalls, and even you have like manual scaling and maintenance. You have like fixed capacity where you have to predict how much computing power you would need, and the IT teams will keep on patching, they keep on upgrading and troubleshooting the hardware. And then there is going to be disaster recovery risks. So you have to set up the backups manually. If something goes wrong, then you have to take it from the disaster recovery, right? And then high energy and real estate costs. And that's for sure. So you're going to pay for electricity, for big air conditioning, and even the data centers needed surveillance and physical access controls. When it comes to the cloud infrastructure, you're going to set up everything in virtualization, like virtualized computers, virtualized storage. So cloud providers like AWS, Azure, and Google host your computing power, and those data, the applications, any data that's related to the application that you build will be stored in highly scalable remote locations. You're going to only pay for computing time, not for idle servers. And when it comes to auto scaling services, you're going to the resources, as I told you, it will expand, it will shrink based on your demand, and the providers protect our data with encryption and compliance. And then we have disaster recovery built in, where we are going to do automated backup and multi-region replication. Sorry. And then when it comes to cost optimization and pay as you go, so we pay only for what we use instead of owning the entire infrastructure, and the data centers efficiently share the resources across clients, and there is going to be no need for big data centers, just a cloud account. And now let's move on to the next slide, where we're going to see about the similarities between on-prem and cloud testing. What are all these similarities? So far we saw about the differences. Now in this slide, we'll see what are the similarities between on-prem and cloud testing. So now this is the critical part, which is understanding the similarities between the on-prem and cloud testing or the cloud infrastructure. So as a performance test engineer, we all know transitioning from on-prem to cloud changes how we monitor, how we test, and how we optimize the applications. And this slide that I'm showing you represents the evolution of infrastructure from fully managed on-prem solutions to cloud managed services like IaaS, PaaS, and SaaS. So IaaS is infrastructure as a service, PaaS is platform as a service, and SaaS is software as a service. So when it comes to on-prem, the traditional model where everything is our responsibility. So in an on-prem setup, performance testers must manage the server load balancing, where we manually configure how traffic is distributed. And when it comes to resource allocation, CPU, memory storage, and networking must be sized properly. And when it comes to scaling strategy, we have to do vertical scaling, where we can upgrade the hardware, and that's the only way where we can do, which is slow and expensive. And when it comes to monitoring and fault tolerance, it requires dedicated tools, which is Nagios, Prometheus, whatever tools we want, we can actually use it for monitoring and fault tolerance. And when it comes to disaster recovery and backups, we are going to have high maintenance efforts. So now the point here is the performance testing challenges. So we simulate traffic to see how our system handles peak loads and stress conditions, but we are constrained about fixed resources, no auto scaling, because it's not even possible here with on-prem. And hardware bottlenecks means upgrades require physical intervention, which makes the capacity planning very critical. And when it comes to cloud migration, we do have IaaS, PaaS, and SaaS, where we can do auto scaling, and it is elastic load balancing. The resources which we use, they dynamically adjust based on demand. And when it comes to compute and storage on demand, so there are going to be no upfront hardware cost, which reduce the over provisioning risk. And when it comes to serverless and containerization, so there are going to be like fast deployments using Kubernetes, AWS Lambda, or Azure functions. And when it comes to performance monitoring built in, so cloud native tools like AWS CloudWatch, Azure Monitor, and Google Ops. So these are the performance monitoring built in tools. So what are the challenges that we're going to face? So starting with uh, the stress testing. So instead of stress testing the fixed infrastructure, we must focus on cost efficient scaling and how elastic the system is. And nextly, we should check for latency and API performance, which are the critical factors or the critical metrics due to the multi-region cloud deployments. And then we have to do the chaos testing, which is needed to simulate the outages, which ensure systems fail gracefully in a distributed architecture. So now what happens is what was removed in the cloud migration. What happens? What happens in this scenario? So there's going to be no more manual scaling. Auto scaling will be replaced, which is going to be part of the cloud migration, and there is going to be no need to maintain any physical servers and cooling. You're going to, like, the providers will handle it. So no separate disaster recovery setup, multi-zone redundancy is built in. No heavy network security configuration. The cloud providers enforce global policies. So what was added in the cloud migration? The first thing is cloud load testing. So you're going to simulate the global traffic to validate the latency and failover scenarios, and serverless performance validation, where you're going to ensure the function execution times scale efficiently. And when it comes to dynamic cost optimization, you're going to monitor the CPU, the memory usage to prevent any spikes, any billing spikes. And when it comes to multi-region stress testing, you're going to validate resilience when an entire data center fails. So all these are part of your cloud migration and part of the testing and performance testing. So the final takeaway for the performance testing just to us is like, when we are migrating from on-prem to cloud, it's not just about moving the servers, it's about redefining the performance testing strategies for a scalable, elastic, and cost-efficient architecture. So the old approach could be like you have a fixed capacity testing for known hardware limits, but the new approach is going to be like dynamic, serverless. It's going to be auto-scaled testing focused on speed, cost, and reliability. So your job as a performance test engineer evolves from handling static resource constraints to optimizing the cloud elasticity, where we're going to ensure the system is cost efficient and resilient. So tomorrow we're going to see about the key differences, like the resource scalability, the network latency, and how are we going to use the monitoring tools in both cloud and traditional. And we are going to also going to see the pricing models, the pay-per-use, the fixed cost, and we're going to even define the SLAs and KPIs which we initially had for on-prem. Now it's going to be a little bit of changed manner. We're going to even identify the critical transactions. How are we going to do? How did we do the baseline metrics in on-prem, and how did we analyze the network latency? We're going to see all this checklist in the upcoming videos, and we're going to design workload models for cloud, the plan for failover and recovery. We're going to even see the benchmarking strategy, because this is very important, right? Before we even move it to cloud, we must have a benchmark of all of these. And we're going to see how to do the execution strategy and the sign off part as well. So if in case, like whatever we have taken, I have taken today until now. So if you have any questions, or if you have any points, or if you want to know in particular area of it, please do comment in the comment section. I'll discuss that in the next video. So until I see you all in the next video, it's bye bye from Vasan Shanmugam and your favorite Little Sla YouTube channel. Take care and bye bye.